So let's take a look at some nice new features coming in DCOS 2.0. So what we'll do at the beginning is that we'll start by creating a new folder, and we'll also define that we want to enforce the quota for this one, because as you can see here, there is no quota defined. And just go there, create first of all enforcing the role, make sure that you can only run application with the right role, and then creating a quota like you can see there. So now that we have a quota in place, what we can do is that we can deploy a Kubernetes cluster inside this folder, and we'll see that the quota will display the current usage of our cluster that is currently being deployed. And as with the other services, we are running a plan, and when this plan is complete, we have the etcd and the control plane and the kubelet running for that cluster, and we can take a look at the quota, and we see that we have used most of the resources that were allocated. So now what happens if I try to deploy a second cluster with the same size? Obviously, I will reach my quota. So you see the deployment has started, but it is stuck in the plan. It cannot continue to deploy more components because the quota has been reached. So what we can do here is it's quite easy. We can just go and update the quota to provide more resources. And as soon as we have done that, the other task will be deployed. So we just go back to the command line and just do a DCOS quota update, giving more CPU, memory, and disk. And automatically we see that the new components are being deployed, and the plan will execute up to the end. So quite easy, quite straightforward. You can now let end users deploying their own services without worrying about the overall resource consumption. So you can give some resources to a BU, and in this BU they deploy whatever they want. Another nice feature in DCOS 2.0 is the ability to put a node in maintenance mode. So we are looking for nodes and what are the components running on them. So you see different examples. So let's find one that has at least like two components. Okay, one of each cluster, so that's perfect. So we have one control plane of each Kubernetes cluster running on this node. So what we'll do is we will put this node in maintenance mode, what we call, as you can see here, drain. So we just drain it, and what happens is that these control planes corresponding to the Kubernetes cluster, they will not be restarted in another machine automatically, because we have three control nodes and we can survive with two. So it's just like a quick maintenance. We don't need to restart them somewhere else. We could send a request to have them reallocated to other nodes, but it's most of the time not necessary. It's more when you have a definitive loss. But then what we can see here, that when we reactivate these nodes, automatically it will be detected by the SDK, and the service will be just restarted correctly. So the task corresponding to the control plane will be automatically restarted, and you see there is a recovery plan to make sure that when the task is restarted, then it joins the cluster correctly, and everything is fine. And we can see that on both clusters. Another nice feature of DCOS 2.0 is what we call the self-service EdgeLB. So it allows to deploy an application on Marathon and being able to set load balancing rules directly in this app, like it was possible with Marathon LB in the past. So we have like EdgeLB here that is deployed under this directory here. And what we will do is that we will create a template that can be used for these Marathon apps that will want to use EdgeLB to expose their application. So we start by creating a template. Then we'll want to modify the template. So just go and get the current one. For example, we have two public nodes here. So we want to make sure that every time we expose an application, we expose it on the two public nodes to get high availability. And then we just update the template. So now let's create an application. So we just go there and say we want to run a new service. And we provide the JSON definition. And you see here, the most important part, we want to expose it. We want to use this customized template, and we want the application to listen on port 8080. So we just click on run. What will happen here is that the application will run and automatically it will be detected, and the pool, the corresponding pool, will be deployed on EdgeLB, like you can see here. And we see we have two instances of it, one on each public node to get high availability. So now we should be able to access our application on this port 8080. Okay, so that's just like showing you how to apply a basic rule to get the application accessible from the outside world. Now we can take a look at some other advanced options. So we can just go and set some other parameters. For example, we probably want to expose it with a specific DNS name. Here it will be www.test.com. So I can just update the service, and obviously we need to update my etcos file so that it is correctly resolved. So I can save it, and I should be able to go to test.com 8080, and if I go to without the name, it doesn't allow me to access it anymore. So I can go again, edit the service, and just say I want it to be accessible on this specific path. So I can update it here. Again, the new configuration will be used quite quickly, and I can now just add path. And you see I get the 404, but it gets a response from the container, but just tell me that this path doesn't exist. So here it's quite easy. I need to use a rewrite rule. So I go there again, and I'm just adding that rule here, saying I want to rewrite from /path to /. Again, just run my service here, and if I go there, now it goes back to the right page. Also, I very often want to use HTTPS. So again, it's quite easy to do. Just say I want to use HTTPS. I could use like a certificate from the secret store, but here, just to make it easier, I will use auto-generated one. So just say I want it to be auto-generated. Again, the application is restarted with the right stuff, and the Nginx server that's running in this application is exposed through our EdgeLB pool, but in this case I can use HTTPS. And still I'm able to access this application. Okay, so finally, let's have a look at another nice new feature, support for Windows Agent on DCOS. So that's really nice. It has several use cases. We will show you two. So here we have like several nodes, one Linux public agents, one Linux private agents, and two Windows private agents. Like you can see here, the OS is written Windows. So we've deployed Jenkins there. So just open the Jenkins here, and we have like created a pipeline. This is probably the most simple pipeline you can create because it will just display the version of your Windows agents, but it's just to prove that you can run execute a pipeline on a Windows Jenkins executor. If you can do that, obviously you can do anything that you would normally do with Jenkins. So what I'm going to do is just like starting this pipeline here by clicking on build now, and we'll see that will be quickly executed here, and we see that an executor has been launched on one of my Windows machine here, and you see this guy will disappear after a few minutes. It is just like created when you launch a pipeline, so that you get like on-demand usage of the resources. You don't have to dedicate resources for these Jenkins executors. You just have them used whenever pipelines are running. So another nice feature we'll go through very quickly is the ability to run a Windows container, like in a Marathon app. So I'm going to just create a single container, taking this example there, just a .NET application. I just need to change that value because this is the DNS name of my public node I need to indicate there. Okay, and then you see the constraints OS like Windows is telling Marathon that I want to run that Windows container, not a Linux one. So just click on run, and what will happen is that this application is going to be deployed in one of the Windows nodes. So again, going there, I see that it is running my application, and I should be able to access it with this DNS name that I've indicated because I'm using MarathonLB to expose it. So very straightforward. And now if I'm going inside this machine, which I have somewhere here. So if I go inside this machine, I can do a docker ps, and I see that I have my application running there, and I can just remove that, kill that guy here, and I get the same benefits I get generally with my Marathon apps, is that this application is automatically restarting and will be quickly available again. So will be restarted on that Windows machine, or perhaps on the other one, in fact, because I have two of them. So just need to take a look there. Yeah, you see this is starting on the other one, and as soon as it will be running, I will have this page available again. I could have done like instances equal to, so that I get like two instances of my app, and I don't even suffer when I kill one of the container, but just to show you that you get the same benefits you get with Linux containers. So I'm going there, trying to access it again, and you see I can access my application. So that's it for the Windows support, very straightforward, allow you to run Jenkins jobs easily on Windows servers if you want to build a lot of code, and also allow you to run .NET applications on Windows. Thank you.